Hello everybody, welcome to this video giving an introduction to 11.9, which is representations of functions as power series. So in this section, we're going to be interested in two things. The first is trying to find power series representations of more functions. So right now we're pretty limited to 1 over 1 minus x, but we're going to see how to use either algebra techniques or calculus techniques to find power series representations of other functions. And then once we've done that, we're going to use these power series representations to accomplish various calculus tasks, like differentiation or more likely integration of different functions, because integration can be quite challenging. Okay, so let's get started. And this video is going to be just looking at using algebra to find representations of other types of functions. So it's going to be pretty short, and then in the next video, we'll look at using calculus. So how do we do it using algebra? So everything is based off, we saw that 1 over 1 minus x is the sum of x to the n from n equals 0 to infinity for absolute value x less than 1. So we saw this in the previous section, and it was based off the fact that the sum of x to the n from n equals 0 to infinity is a geometric series with first term 1, common ratio x, so it converges to a over 1 minus r, which in this case becomes 1 over 1 minus x. So this is by itself is pretty limited, but we can also use algebra and later calculus to get more power series from this. So if we use algebra, what can we do? Well, here are some things we could do. So we could replace x by a multiple of x or a power of x. So everywhere in this formula, for instance, we could replace x by 2x. It would still be a perfectly good formula. We could replace x by x squared. It would still be a good formula, something like that. We could multiply or divide by a constant or a power of x. So, if I have a representation for 1 over 1 minus x, I could get a representation for 5 over 1 minus x just by multiplying both sides by 5. One thing to be careful about, though, in the second point is if we're dividing, we want to make sure we still have a power series. So if my power series starts with a 1, then I don't want to divide by x, because then I would get 1 over x, which is no more a power series. But if my power series, say if the, if later I end up with a power series which starts with an x, then it will be perfectly fine to divide by x. So with division, just be careful to make sure that you end up with a power series. Okay, and then if we have two power series, we can find the power series for the sum of those, for the sum function, just by adding the power series. So let's see an example of what I had in mind. So let's try to find a representation for 1 over 1 minus 5x. Okay, and in this section, pretty much things are going to start from representations of 1 over 1 minus x. So we start with 1 over 1 minus x is the sum of x to the n for absolute value x less than 1. And then everywhere the x gets replaced by 5x, right? So we take this formula, all the x's become replaced by 5x. It gives us 1 over 1 minus 5x is the sum of, and then not x to the n anymore, but now 5x to the power of n. So we have the sum of 5x all to the n. Okay, and we can multiply that out. It becomes 5 to the n times x to the n. So 1 over 1 minus 5x is equal to the sum of 5 to the n times x to the n. Okay, and as usual with power series, we still want to know when this is true, but luckily there is an easy way to figure out when this is true. Also, in the condition from before, absolute value x less than 1, we replace x by 5x. It's true for absolute value 5x less than 1, or equivalently, if we divide both sides by 5, absolute value x less than 1 over 5, which would be x between negative 1 over 5 and plus 1 over 5. So this was a pretty typical example. We replaced x by negative 5x everywhere in the formula. Okay, or if we wanted to find a representation for 1 over 1 plus x, so don't get confused. The simple formula that we're starting out with is a representation for 1 over 1 minus x with a negative sign there. So if we want to have a representation for 1 over 1 plus x, then we know that negative x is equal to plus x. So if we take this formula and replace everywhere x by negative x, we're going to get 1 over 1 plus x. So we go ahead and do that. Replace x by minus x. 1 over 1 plus x is the sum of minus x all to the n. Okay, minus 1 to the n times x to the n. And as before, we use the fact that it's true for absolute value now of minus x less than 1. So that's equivalently, because absolute value gets rid of any negative signs, that's equivalent to absolute value x less than 1. So x is between negative 1 and plus 1. Okay, so these were some pretty typical steps. We start with 1 over 1 minus x, and we replace x by 5x or minus x, or it could be x squared, or it could be x cubed, or something like that. We'll see more examples later. Okay, another thing we could do, for instance, is multiply both sides by something. So we saw on the last page, 1 over 1 minus 5x is the sum of 5 to the n times x to the n, at least for absolute value x less than 1 over 5. And if we multiply both sides of this equation by x squared, we would get x squared over 1 minus 5x is the sum, and then we multiply all the terms by x squared. We would get 5 to the n, x to the n times x squared. X to the n times x squared will be x to the n plus 2. So x squared over 1 minus 5x will be the sum of 5 to the n, x to the n plus 2. And when we multiply both sides by x squared, the series converges. sorry, the area where the series converges remains the same. So it's still absolute value x less than 1 over 5, or x between negative 1 over 5 and 1 over 5. So that only changes when we make a replacement of x by something else, like x replaced by 5x, and so on. Okay, so that about wraps it up for algebraic techniques. We're going to see lots of examples of these, but basically we start off with 1 over 1 minus x, we replace x by something, or we multiply both sides by a common factor, or maybe we add two series or something like that. In the next video, we're going to look at how to use differentiation and integration to get more series. Thanks everyone, see you next time.